Assalamu alaikum, dear students. Today we are going to discuss about the silicon control rectifiers. But before going into details of silicon control rectifier, we need to look into the diodes. So let's start. As we know, the diode is commonly used for converting alternating current into DC direct current. But the problem with the diode is that it has no control at its output power. So if we need to control output power of the diode, so there's no control. So for this matter, to solve this matter, we have another device which is called silicon control rectifier. So as I told you that if going into detail about the silicon control rectifier, I just want to tell you a little bit about diodes. So I'm going to start my simulation software. Here's a button for new project. I'm going to pick the diode from the selection menu from here. I need a sinusoidal source, and then I need a load as a load resistor. I have to connect like this. Okay, so I have to adjust the load values. I have to adjust the input voltage as 220 line voltage, and the frequency is 50 Hertz. For monitoring the output waveform or looking into the output waveform, I need a voltage probe over here. So this is basically output voltage, and I need that's it. And then I need a simulation timer that I have to decide that how much time my simulation will run. So I have adjusted 100 milliseconds, and then I have to press the start button. Now as you can see, these are the properties that what I want to monitor. So I want to monitor the V out of our system. So I have added this over here. Now you can see that the half wave rectification has been done. Okay, so in this circuit diagram, you can see that the input power is directly coming from sinusoidal source and going into the diode, and diode is directly connected with the load. But in this scenario, I don't have any control at the output level to control the power to directly deliver to the load. So we need, if really we need to control the power, we need a silicon control rectifier, which can be used as a rectifier, but control rectifier. Okay, so now I'm going to change the simulations. Okay, from here I have to delete this, and then this Now I'm going to pick the thyristor SCR, and I'm going to connect the load over there. Okay, and then I need to connect this. Okay. I have to connect this. I have to adjust. I just said already 10K load, 220, 50 Hertz. Now for this device I need a getting signal for triggering the SCR basically. So I'm going to connect the getting block. Okay, so I have connected over there, and then I have to adjust the frequency. As our line frequency is 50 Hertz, so I have adjusted the 50 Hertz as the get signal. Now I have to adjust the switching points. What does it mean by switching points is if we have a sine wave which can be considered is in 360 degrees. So since this SCR is half wave rectifier, so it will work from 0 to 180 degree, and if it's a complete sine, it will work with 360 degrees. So I have to adjust the switching points, 45, let's suppose 60, and then 90, 90, 120, and then 180, let's suppose. So these are 1, 2, 3, 4, 5, 6 points. So I have to adjust 6 points over there. Okay, so now we can run the simulation. We can see the output. Now you can see this basically. Oh yes, one thing has been missed. I have to adjust the holding current and the latching current. So 0.001, and the latching current is 0.1 amperes. Okay, so now we can run. Now you can see the upper part of the sine wave is controlled. Okay, it can be controlled. Okay, so now if I change the switching points from here, I mean these are basically triggering points. Okay, firing angle, as you know, these are the firing angles basically. If I say 90, okay, 0 and 90, 2 points, so I can see my output like this. Okay, this is basically a 90 degree firing angle. Okay, so like this we can control the output of our system. Okay, so this is the solution for the half wave rectifier. These rectifiers are the AC to DC converters. But if I need control of AC power, so we need triacs. Okay, so triac is a device which can be used for controlling AC power. So I'm going to take another device. Okay, okay, so basically I want to take another device. Okay, so I have to connect this device with my circuit. Okay, so I need to connect the getting signal over here. Okay, I have to adjust the holding current and the latching current. Holding current is 0.001 and the latching current is 0.1 amperes. Okay, so if I press simulation button, okay, as you can see, I have to change again the switching points. Let's say again 0 and then 90. 90, then 100, then 200, then 260, and then 280, and then 300. So I have 1, 2, 3, 4, 5, 6, 7, 7 points. 7 points. So 7 switching points, different firing angles. So if I press the what's the problem? What's the problem with the simulation? Okay, I have to give space. I think so. Okay, now you can see the wave can be controlled. These are these waveforms can be controlled easily by applying gate signals to the triacs. Okay, so as we are well aware about why we are controlling these devices, why we are concerned to control the output power of our devices. Let's suppose the application of these devices is when somebody wants to control the speed of the fan. It can be used if we want to control the light intensity of the light bulb. Can be this system can be used over there. So for today, this is the lecture, and next week I will give you the details of triacs and different circuit applications in industry and that how industry is using these devices. So thank you. Goodbye.